Nigel, thanks so much for coming and making the time to do this interview. You're here at the Euroseeds Congress to speak about low acrylamide wheat. What is that all about?
Well, acrylamide is a processing contaminant, only discovered in 2002, and quite a big issue for the food industry because it's carcinogenic, at least in rodents, and regarded as probably carcinogenic in humans. Also has some other effects on development and fertility, so highly undesirable chemical to have in your food. And it forms during just normal cooking, high temperature processing, over 120 degrees, so you're talking about frying, baking, roasting, and from natural precursors, which of course makes it more difficult. There's nothing being added, so you can't take it away. And it's become, as I said, a big issue for the food industry because the European Commission has been gradually tightening regulations. So we currently have benchmark levels for the presence of acrylamide in food, and it is present in lots of everyday foods, and bread, particularly when toasted, breakfast cereals, biscuits, crisp breads, for example, and also potato products, fried and roasted potato products, and coffee, I'm afraid. So a lot of your favorite foods contain some acrylamide, some more than others. So these benchmark levels are set at different levels for different foods. They're not a safety limit. They're what the Commission believes industry ought to be able to achieve. And in this attempt to take out the very high acrylamide products. So it forms, as I said, from natural precursors. Those are reducing sugars like glucose, fructose and maltose, naturally present in cereal grains, for example, and an amino acid, asparagine, only in its free form, not when it's incorporated into proteins. But it turns out that wheat grain, and actually potato tubers as well, have very high concentrations of free, soluble asparagine, and this can be converted into acrylamide during cooking and processing. So we think we can reduce the levels of free asparagine substantially without affecting the development of the grain. That's the hypothesis anyway. So we've looked at the genetic control of free asparagine accumulation in wheat grain, and it turns out wheat has 5 genes that encode an enzyme called asparagine synthetase that makes asparagine. And one of those genes is most active in the grain. So it's an obvious genetic target. So we've taken that genetic target and we've basically knocked it out using the CRISPR-Cas9 technique. So we have plants with every version of that gene knocked out. And also plants with only partial knockouts, just in case there was a negative effect on grain development. And that's been going on for a number of years, and it culminated in a field trial from 2021 to 2022. So that was the first CRISPR wheat field trial in Europe. We've just harvested it, 2 months ago. We've analysed the grain, and it looks really good. So free asparagine concentration is just about a half, just slightly under a half of the unedited controls in the field, which is actually, in the field is the real test of whether or not your technology is working. So we're really excited about that. We are writing up a paper to publish it, and that's where we are.
Wonderful. Very, very exciting, very, very great news, of course. And this is the type of innovation that we need for, getting rid of the bad components in our food and making our food healthy.
Safer, yeah.
Yeah, safer, exactly. Yeah, wonderful. You mentioned you developed it with CRISPR-Cas9 or one of the other
CRISPR-Cas9.
Cas9. Yes. And so we know that CRISPR, of course, has generated a lot of attention in the last few years, received the Nobel Prize for the 2 developers. But Europe is rather cautious and is classifying it now as GMOs. The regulation needs to be done in the same way as GMOs. What are your thoughts on that national or perhaps regional divergence in the regulation of CRISPR and other gene editing?
Well, what a question that is. So first of all, Yes, so under European regulations, we have to treat gene-edited crops as if they were GM crops. And an edited gene as if it were a transgene. It's not a transgene, but we have to pretend it is under the European regulations. So Europe is almost unique in that. Maybe New Zealand is in the same state. But even countries like Japan, who were pretty well implacably opposed to GM, have adopted gene editing. In fact, we saw the first commercial gene-edited tomatoes coming on the market in Japan last year. And in fact, I was in Japan last month and at a gene editing conference, and you've got companies piling into it. Small companies, large companies, companies you've heard about, companies you've never heard about, piling into it, investing. They're already way ahead. Europe is way behind already. Now, and of course, also diverging from its major trading partners. So we get the same headaches that we've got with GM. The UK, on the other hand, is trying to change, or is in the process of changing its regulations on gene editing. So it will be much easier to commercialize gene-edited crops. And in fact, they've already changed the regulations on field trials. So they use this term, a qualifying higher plant. That was an update of the legislation that was already in place, which rolled over from the EU at Brexit, which enables us to do a field trial of gene-edited crops, as long as they're not GM, okay? Relatively easily. I mean, extremely easily, basically. I mean, it's a simple notification to our Department for the Environment, Food and Rural Affairs. And we are also in the process of, or the UK government is in the process of getting new legislation through Parliament, which will allow the commercialisation of gene-edited crops. And of course, all the chaos at the UK government level at the moment, I don't know what's happening to that bill at the moment. I think it's in the upper house, the House of Lords, but we're hopeful that it will go through, and it will go through as it is without amendments. If it does set the scene for commercialisation of gene-edited crops in the UK. Now, of course, there's issues then because obviously the EU remains major trading partner and all that. But it sets the scene. I think plant breeders will probably need not only the right regulations, but maybe more to give them confidence to really start using gene editing and adopting gene editing genotypes to come into their breeding programs, because it's a long process. So 5 to 10 years, for example, if we were to give our gene edited seed to plant breeders, and we have a number of plant breeders involved in our supporting our work, it would be still 5 to 10 years before they got a new variety on the market. Mm-hmm. They'd have to cross the trait into their breeding programs and then produce commercial varieties. Now, to go through all that process, then they need to be confident at the end of it, the rug won't be pulled out from under their feet and they lose all that investment, and also have all the issues of getting the trait out of the breeding program. Mm-hmm. So I think they will need to be very confident that it's all going to be okay, having got their fingers badly burned over the GM issue 20 years ago. Mm-hmm. So I think there's that. Another thing to consider is that the kind of mutations that we've introduced, for example, using gene editing to knock a gene out, they occur naturally all the time. And in fact, one of the genes we work on, many varieties contain a large deletion that has taken out that gene, one of those genes, quite naturally. And this deletion is present in some wild wheat relatives as well. It's just slightly ironic for me that, of course, that deletion is perfectly okay under EU regulations. But if you make a much smaller deletion using CRISPR-Cas9, and there's lots of regulations that, we could go. We all know the kind of ironies of the regulations. But the point is, how do you detect it? Mm-hmm. So with GM, you can only detect something because you know it's there, right? You use PCR technique.
Yeah, exactly.
And you do it on the genes you know are there. But GM is regulated everywhere. So you know what to look for. Variety X has these GM components to it, so you can test for that. And then is it approved in Europe or not approved? If it's not approved, you can turn it away. Gene editing, it's not regulated in the US or Brazil or Argentina, all supplying us with, huge amounts of commodity crops. So you might know now what gene editing is going on. 10 years from now, other plant breeders have taken an edited trait into their breeding programs. It's been moved around. Farmers have crossed them, whatever. You don't know what's going to be coming and what's not. And it looks just like a natural mutation, so you can't be sure where it's come from. If you've got a soybean gene in wheat, then, that sticks out like a sore thumb, if you see what I mean. But if there's just a small deletion in a gene, how do you know where it's come from? So I think the EU actually does recognise that fact. And it's one of the reasons why the EU is at least looking at new regulations on gene editing. Of course, it's moving at a snail's pace. We're old Europe, okay? We don't need to rush with these new technologies. Our position in the world is, and we'll always have enough food because we'll just buy it off poorer countries. We've got more money than them, so we'll outcompete them on the world markets. It's all okay.
Very true.
Sorry, I'm being a bit sarcastic.
No, but it's of course all very true. Nigel, you mentioned it already a bit before. UK is now outside of the EU. Do you, as a scientist, feel you have more freedom in your research, for example, on the field of gene editing?
Well, we do on gene editing. That's a fact. And it's, can I say I was a Remainer? A Remainer, very pro-Europe. It's ironic for me, but we'll take it that we're able to do this. And it's certainly, I don't know, but I think it's one of the motivations for what is still a pro-Brexit UK government to show we can do some things we couldn't do before. Whether actually crop biotechnology is the right, I don't care, but they're doing it, so that's good. But we should note that it's only in England. We have Welsh and Scottish governments are not following suit. So the power has devolved to them, and they're not following suit. And of course, if you're cynical, you might say, what are the reasons the Scottish government is not following suit? Because it wants to show that it could be different to England. And also, we have a pro-independent Scottish government which would like to break away from the UK and rejoin the European Union. So remaining aligned with the EU probably suits them better. But so you get all these, and of course this is what happened with GM, They got all sorts of political stuff tied in with it. It was never a scientific question. And it still isn't now. Is there any question about the safety of GM? Of course not. It's been grown and eaten for a generation now, around the world, billions of meals. And of course, the EU imports millions of tons of GM soybean, GM maize, and cotton. So, most of that goes into animal feed. Not all of it, but most of it goes into animal feed. But it goes into the food chain, right? And no one is remotely worried that there's a safety issue associated with that. So let's not pretend that the EU thinks there's a safety problem with GM. So what is the problem there? Why do you still, we have, when was the last approval of a GM crop for cultivation in Europe? 2010, I believe, 12 years ago. And that crop, the Amphora potato, came and went. It didn't even make it really into commercialization. BASF pulled out of biotech in Europe altogether. Great. Big seed company pulls out of biotech in Europe. This is a disaster, but apparently we don't care. And that's an old story anyway. And the only crop that remains available to European farmers, GM crop, is a maize grown in Spain and a bit in Portugal and pockets here and there elsewhere, which was approved before it became difficult. It was approved in the 90s. So there we are. And that's what we have. And I say we import millions of tons of soybeans and maize. Well, we compete with those as well. Right? We compete with those things. So our farmers are not allowed to benefit from GM technology. Our consumers aren't. There are lower acrylamide potatoes been on the market in the United States since 2016. European consumers don't get those potatoes. Why not? And why isn't that a bigger story, So they're being denied the choice. It's not to say, if you don't, put it on the market. Label the things, put a big, bright label on it. Let consumers choose. Because NGOs are actually afraid to do that. They don't want to do that, And they argue about labelling at the moment in the UK. The proposal is that gene edited crop products would not need to be labelled. I don't necessarily think that's a good idea, because I think the lack of labelling of GM products in the late 90s really backfired. But anyway, that's the policy. Mm-hmm. Of course, NGOs say, well, you need to have labelling. They say, well, getting labelled GM or GE products onto the market is not your policy either. You want to ban them altogether. You don't want to give anybody the choice of anything. So, sorry, I'm rambling now. I'm not quite sure where your question was.
Yeah. Whether you had more freedom now, research freedom in the...
Clearly we have more freedom now. It's one of the ironies is that we had one of our wheat lines. So the gene we targeted was asparagine synthetase 2. And this time last year we were just planting. We had to have a consent to grow them as GM crops. Actually, they still contain some transgenes, because the CRISPR-Cas9 process, the simplest way of doing it is to introduce genes encoding the CRISPR-Cas9 and the guide RNA that goes with it that targets it into the plant. When the editing is done, you can then cross those transgenes away by just normal plant breeding. So, but that's a process, and of course with wheat it takes a little bit of time. So it will be GM anyway. But also, as I said, this time last year, we were having to treat the edited genes as if they were transgenes. So we discovered quite late on that one of our plants had some edits in a very closely related gene, asparagine synthetase 1. Our target was asparagine synthetase 2. It's actually our best plant in terms of asparagine concentration. So I said we're down to about half in the ones we have. This we think would go lower, maybe to a third, but it hasn't been grown in the field. The reason it hasn't been grown in the field was those edits in the ASM1 gene were not described in our application for consent to grow a GM crop, or field release a GM crop. And so we had to keep it out of the field trial for the first year. We've now got permission to grow it in the second year. So hopefully it might be today actually, or this week, depending on the weather, that field trial year 2 will be going in the ground with those plants in them. And then ironically, those are the first plants that we've actually got rid of the transgenes. So we now have transgene-free versions of that line. Not enough to go in the field trial yet, but I'll be bulking those up this year. And those are a qualifying higher plant under the new legislation for field release of gene-edited crops. In the new legislation that's still going through Parliament for commercialisation, they would be referred to as a precision-bred organism, a PBO. That seems to be a term that the UK government wants to push for gene editing. Precision breeding and precision breeding organisms.
Excellent. Thanks, Nigel, for taking the time. It was lovely having you. I enjoyed your opinions, and thanks so much.
Great. Hopefully not too much opinion, but...
Yeah.